Hello everyone! Today is December 25 and it's time to open a new problem from LeetCode for our Coding Advent Calendar. Today's problem is more or less about a thing called binary search. And binary search is implemented in .NET in a very interesting way. Let's check out. Here is the problem. Longest subsequence with limited sum. You are given an integer array nums of length n and an integer array queries of length m. Return an array answers of length m, where answer I is the maximum size of subsequence that you can take from nums, which such that sum of its element is less than or equal to query. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of remaining elements. Example 1. Nums 4, 5, 2, 1 and queries 3, 10, 21. And output should be 2, 3 and 4. For query 3 we need to pick these two elements, so the length is 2. For 10 we need to pick 4, 5 and 1. 4, 5 and 1, right? And for 21 we need to pick all of them, 4. That's it. So this part of description is a little bit confusing without changing the order of remaining elements. But practically it does mean nothing, because we can pick any elements and the only thing we need to care about is the number of these elements, and we can put them in any order actually. So having this, so why I'm saying so, it is because it is stated here that we can get this array by deleting some of elements. So this means we can delete any of them and the rest will be taken, and who cares in which order. So let's do it like this. So first of all, we are interested of taking as many elements as possible. That means we need to take elements with smallest values first, right? That means we need to order our array, we need to sort it. Let's do it in place. Okay, now when this array is sorted, let's do the following. We will modify it in a way it is more appropriate for us to query, because these queries mean sum of elements. So that means when we need to take two elements, that means we need to take 1 and 2, and it is equal to 3. The answer will be 2, but the value is the sum of these two elements. So we care about sums. And for each individual query we need to start from the smallest elements and go further. So we will modify our array to be like prefix array. That means if we have, for example, 1, 2, 3, 4, 5, we will modify it like this. 1, this one will be 1 plus 2, which is 3. This one will be 3 plus 1 plus 2, which is 6. This one is 10. and this one is 15, right? So how we can calculate it very quickly? We can take next value and add previous one, take next, and add previous one, take next and add previous one. So let's do this. For var equal to 1, actually, because we will not modify the first element, I less than nums length I plus plus nums I plus equal to nums I minus 1. So we will modify this array in place. Next, we need to query our modified array m times. So we need to iterate through these queries. Instead of creating a new array, we will also use this array, because once we query, once we take value from this array, we don't need this value anymore, and we can actually use it, reuse it. So how to find a value? Since our array is sorted already, and we just need to find a value with value from queries, we just need to use binary search. And .NET Standard Library has built-in function for arrays to do binary search. Index array binary search in nums, and we are searching for queries I. Okay, so what is this index? If value, for example 3, it will be here, like 1 plus 2 is 3. If the value found, then it is positive or 0, and it points to a new to existing value. If index is negative, that means binary search algorithm was not able to find exact value. But this negative value, this negative index, will be bitwise value of an index which is greater than queried value. For more details, please go to Microsoft documentation about binary search function. So I will just write down the answer here. So we actually need to find an index, right? And that's it. Our index actually, here it will be +1, because we need to return the number of elements. Since we have 0 index array, so index can be 0, which means we need to take first element, we need to add 1 here. And here we don't need to add any ones, because it already points to the next element in an array. Okay, and that's it. Let's run it. Done. Submit. Hooray. So let's estimate the complexity. So the time complexity is big O of n plus m multiplied by logarithm n. N log n is states for this part, this sort algorithm. M log n is for this part, because we need to do binary search of n elements, which is log n, and we need to do this m times. So the answer is big O of n plus m multiplied by logarithm n. The memory consumption is, well, here it is constant time, because we don't use any additional arrays, we just modify existing ones. And if this sort function uses quicksort, it still fits in memory, in place, sort. So in this case we have constant time, constant memory. But if we don't modify our existing arrays, we need to create them. That means we need to have big O of m or big O of n, which is greater so than constant time. That's it. This problem was not very complicated. Only a few tricks with initial dataset and simple loop with binary search. That's it. Many powerful things are hidden in standard class library of .NET, but I'm sure the programming language you use have these features as well. See you tomorrow.